Hi everyone, it's Will. How are you doing? I'm doing great.
Hi, it's Emma here. Let's have fun today.
Hi everyone. Thank you for coming to MINPRO today. Today we're going to work on making a game. I know you've been waiting for this.
MINPRO.
What kind of game are we going to make?
Easy games are boring.
Hey, it's okay if it's easy.
We can only make simple games with Scratch, right?
That's not true.
Can we make an amazing game?
Let's see. I think you can make a fun one. It depends on you. For example, on the Scratch site, you can see games that people around the world made.
Wow! There are lots of programs.
What are the featured projects?
These are projects that people visiting the Scratch site recommend as good programs.
So many people are programming with Scratch.
It's thrilling to think there are people around the world participating.
You too are also going to become one of those people around the world.
That makes me a little nervous.
You'll be okay. There should be elementary school kids here too.
I'd like to see programs made by elementary school kids overseas.
There are many programs made by elementary school students overseas. Take your time looking at them. Now, let's think about what kind of game you're going to make. First, decide the type of play. You could fly through the sky, do a quiz, or you could shoot down the enemy with laser beams. This will decide the type of game to make, such as a 3D simulation, quiz, or shooting game.
I want to make a shooting game, and make it three-dimensional.
Let's make it a game where you catch the enemy instead of shooting.
That's nice and kind.
What about 3D?
Let's make a 3D catching game.
That'll be awesome. I want to make it.
I want to create a quiz.
The person creating the quiz knows the answers, so you won't have fun playing it yourself.
But isn't that true for all quizzes?
Let's think of a quiz that the creator can play too.
Well, how about a maze?
Or find the difference with two pictures.
Will, that's a good idea. Let's try making an aha experience that will train the brain.
Isn't that the game where the part of the picture changes gradually?
That's right. If the changing part varies each time the game is played, the creator can have fun too.
I see.
Okay, let's start with the 3D game.
Making 3D games seems complicated.
With Scratch, you can't make the characters three-dimensional. Instead, you can make the game space three-dimensional.
How do you make the space three-dimensional?
A shooting game scrolls vertically and horizontally. In other words, it is two-dimensional or a plane. If you add perspective, the area will become three-dimensional.
How do you add perspective?
Well, 2D uses an XY coordinate plane, so you need to add another axis. We'll make XYZ coordinates by adding the Z-axis to pass through from the front of the plane toward the back. Three-dimensional is expressed with XYZ coordinates. Imagine that the enemy is in the space. How does the same enemy appear when it is in the distance and when it is close?
It is small when it is far away and big when it is close.
That's right. This is called perspective.
So, if we want to make it look like the enemy is approaching, we need to increase the size gradually.
That's correct.
Doesn't that just make it look like the enemy is getting bigger?
Yes, without scenery in the background, it might look like that. But if you have scenery drawn with perspective drawing, it will look like the enemy is approaching.
What kind of scenery?
For example, this type of scenery. It is drawn so that a point in the distance becomes larger as it nears the front. This is called a one-point perspective and is often used when creating three-dimensional pictures.
I think I saw this in art class.
One-point perspective is used to make the width of the racetrack in Mario Kart look narrower the farther away it is. There are also two-point perspective and three-point perspective drawing methods.
Yikes. I'm not good at drawing, so the easier one-point perspective is okay with me.
Does it look like an object is approaching with this type of scenery?
Let's compare them. The cat's movement is the same.
Wow! I get it now.
When displaying a 3D image, the object's size is calculated based on its distance from the viewer. If the distance is half, the visible size of the object is doubled. The vertical and horizontal positions are also obtained with calculations.
Do you mean the X and Y coordinates?
That's right. Here's the code for programming this perspective. The visible size of the object is calculated by dividing it by the z-axis position. The vertical and horizontal positions are x, y. If the position is 0, 0, it is the same as the viewer's, so it appears to be moving straight toward the viewer. However, if the position deviates, the deviation will increase as the object approaches. How the deviation appears is calculated by dividing x, y, by z, just like the size of the object.
You can't tell when it is far away, but you can see the object deviate as it approaches.
That's exciting. It seems like the cat is going to jump out of the screen when it gets close.
Is this going to be a bump and catch type of game?
Are you going to bump into the object yourself?
Let's put a net in front of you.
If the object touches the net, it means you've caught it.
Then, the net should move in all directions.
The game programming is coming together. Let's add a catching action and a moving net to the code. What do we need to do?
Let's make a net sprite. When the cat touches it, it's caught and disappears. The net can be moved with the arrow keys.
Or, you could move yourself.
That's one way to do it. You always have the net in front of you, and you go to bump into the opponent. Express your position as an XY coordinate variable, and calculate the difference between you and your opponent. It's a little more complicated than moving the net. Select one of these methods and add the program.
MINPRO.
How's it going?
I made it. It was easy.
The cat meows when it's caught.
You did a great job. It's neat that you can tell that the cat has been caught.
It's kind of strange though. The cat is really big when it comes toward the front, but the net is still small.
That's a good point. It happens because the net is right in front of you. Try putting it out forward.
What do you mean by putting the net forward?
Do you mean the z-axis?
That's right. Put it slightly in front of you. It is judged that the cat has touched the net when the cat's z-coordinate is about 5. If you keep the same display, the cat that escapes without touching the net will appear as if it passed by.
I get it.
The game movement feels strange because the calculation is different from the world you imagined. So the net looks small because of the calculations.
There was a reason for it.
The important section of the 3D design has been programmed, so let's work on the game aspect next.
Let's create a scoreboard.
If a cat escapes, you lose a point.
It's good. If you make the score a variable, you can easily display it. Do you want to time it?
It could be a race, like how many cats you can catch in 1 minute.
Okay, let's make the game stop after the set time has passed.
How do we do that?
There is a clock that is constantly measuring how much time has passed from a specific time. It's the variable called a timer in the sensing blocks.
Is a variable a clock?
The variable contains a number to show how many seconds have passed.
That's right. Scratch automatically sets a time in the timer variable. If you put the reset timer block at a time when you want to start timing from, the timer will start counting time from 0 seconds. The unit is seconds.
It's like a stopwatch.
That's right. If you use the events blocks when timer greater than such and such, this block will be executed when the time has passed such and such seconds.
So the game can stop then.
Right. Okay, let's complete this program.
Way to go! We made it!
It's pretty fun.
Right? But it wasn't easy to make.
That's right. It's important to visualize the three-dimensional space.
Next time, instead of cats flying one by one, I want a whole bunch of cats to come flying.
Can't you do that by duplicating the sprite?
Yes, you just need to make clones.
What's a clone?
In Scratch, it means to duplicate a sprite while the program is running.
Don't you click the sprite and then copy it?
No. You can duplicate the sprite while the program is running. That's why you only need one sprite.
That's handy.
I'll explain how to make a clone during another session. This is what you can do with a program using clones.
Cool. Lots of cats are flying toward me.
It looks like a real game.
In this game, instead of moving the net, you have to move to catch the cats. When you move toward the cats, it looks like they are approaching you. In 3D games you can buy, the coins suspended in the air that you get by jumping are drawn with the same calculation method.
Scratch is so cool. It's great.
It seems so simple, but we can do amazing things.
The great thing about Scratch is that it's object-oriented and event-driven.
Oh no, that doesn't sound very easy.
We're going to study it properly though, right?
Yes, but...
Let's talk about Scratch in detail some other time.
By the way, what about the aha experience?
Let's talk about that separately as a continuation of Chapter 4. Next time, we'll learn about moving a robot. I hope you'll join us.
Bye-bye.
See you again soon.